In this course, we are again going to talk about limits, but we will be talking about the L'Hopital's rule, okay? And a lot of you in Calc 1, I've seen that you know how to use L'Hopital's and you were excited to use it in some exams, and then I have to tell you that no, you cannot use it yet, okay? But you will be able to use that pretty soon. So let's review limits. So let's say I have to compute the limit. I have to compute the limit as x goes to -3 from the right side of -3, x plus 2 divided by x plus 3. Okay, so that's the problem. And so how do I compute this limit? So let's say here is -3, here is -3, and x is approaching -3 from the right side of -3, right? That's what's the meaning of plus. So I have this, that x is going to -3. And let's see what's happening to the numerator and the denominator separately, okay? So what's going on with the numerator? Here I'm graphing x plus 2, right? So is it clear that x plus 2 will be approaching -1? So if I have -1 here, then x plus 2 is going to approach -1 like this. You agree with that? As x gets closer and closer to -3, x plus 2 is going to get closer and closer to -1, right? Everybody's okay? And in fact, it's going to go to -1 from the right side of -1 because your x is larger than -3, right? Where is that? Oh, no, actually, this is what I said here is wrong. Sorry. X plus 2 is going to -1 from the right side of -1, right? For example, when x is -2, you get 0, right? So x plus 2 is going to -1 from the from the left side of -1. How about x plus 3? Obviously, x plus 3 is going to 0 when x is going to -3, right? You agree with that? So here is 0. My question to you, does x plus 3 go to 0 from the right side or the left side? What is that? So here, what is that? Here I have that x is greater than -3, right? X is greater than -3, so that means x plus 3 is what? Greater than 0. So that tells you that x plus 3 is going to 0 from the right side of 0, right? Am I making sense? So x plus 3 is positive. X plus 3 is positive, and it's going to 0, okay? Is everybody okay? So why is that necessary? Well, what we are saying is that the numerator is getting closer and closer to -1. So when x is very close to -3, on the right side of -3, the numerator is a negative number, right? What's the denominator? The denominator is 0, close to 0, but positive, right? So denominator is close to 0, but positive. Okay, so when you have a fraction, the numerator is approaching a negative non-zero number. The denominator is approaching 0 but positive. So what's the limit of the ratio then? What's the rule? What will be the limit? This limit will be negative infinity, right? Why negative? Because the denominator stays positive, the numerator becomes negative, right? So the ratio is negative, right? The ratio is a negative number. However, because you are dividing by a smaller and smaller number, the fraction is going to get bigger and bigger, right? Think about when x is like 0.1 trillion zeros and 1, right? 0.1 trillion 0, 1. If you divide a number by that, the ratio would be what? Big, right? Is everybody clear? Always remember. I don't want to say that. Remember what I said in Calc 1, because not everybody was in Calc 1. But whenever you have a fraction, if the limit of the numerator is non-zero, the limit of the numerator is non-zero, limit of the denominator is 0, then the ratio has limit plus or minus infinity. Is it plus? Is it minus infinity? Depends on the sign of the fraction when x is close to the limiting point. So what we decided was when x is close to -3, numerator is close to -1, denominator is close to 0 but positive, right? So we know that it has to be negative infinity, not positive infinity. Is that okay? All right.
Why is 0 positive?
0 is not positive. We are saying that when x is pretty close to -3, right? So when x is pretty close to -3, but on the right side of -3, right? When x is close to -3, so this gap is going to 0, right? The gap between x and -3 is going to 0. So when x is close to -3, but on the right side of -3, then x plus 3 is a positive quantity, right? X plus 3 is a positive quantity when x is on the right side of -3. So this x is going to -3 slowly from the right side, and when that happens, x plus 3 is going to 0. X plus 3 is going to 0, but the sign of x plus 3 is positive, right? If I have that x is going to -3 from the left side, then what's going to happen is that x plus 3 will go to 0, but it will be negative, right? You realize that? For example, what if x is, say, negative 2.99 or something, okay? So this will be on the right side here. So what will be x plus 3? It will be a positive quantity. Yeah, so x is greater than -3, x plus 3 is positive. Is everybody okay? Is that making sense? All right. Okay, so the answer would be negative infinity. Another example. Let's say I have the limit as x going to 5, and I have x squared minus 6x plus 5 over x minus 5. Okay, what's the limit now? You always should, whenever you have a limit problem, you should always plug in the limiting point for x and see what you get, okay? So when x is, as x goes to 5, what's the limit of the numerator? Can someone tell me what's the limit of the numerator? 0. When x is going to 5, what's the limit of the denominator? 0 as well. Does that tell me what the limit is? No. 0 over 0 does not tell me what the limit is. So, but what's the trick that we learned in Calc 1 when we see that the limit form of a fraction is 0 over 0? When the limit form of a fraction is 0 over 0, what trick? Yeah, you could. That's one trick that you could do, is multiply and divide by x plus 5, or you can factor out. Okay, So in this case, because these are polynomials, we can factor them out, right? So as x goes to 5, the numerator can be factored out as what? Very good. So this is... So the numerator can be factored out like this, and then we can cancel out x minus 5. And then now if I plug in 5, what do I get? 5 minus 1, which is 4. Is everybody okay? Remember, when you plug in something for x for a polynomial, you get 0. Always remember that means 5 is a root of the polynomial, right? If 5 is a root of the polynomial, it means the polynomial can be factored out, right? If you have a root of a polynomial, the polynomial can be factored out by using that root. Okay, so here's that. Please feel free to ask questions if you have any. Let's say I have the limit as x goes to negative infinity of 3x minus 2 over 2x plus 1. What's the limit now? Yeah, as x goes to negative infinity, the numerator goes to negative infinity, the denominator goes to negative infinity. Does it tell me what the limit is? Yeah, it doesn't tell me what the limit is, right? Yeah. Go ahead. Yeah, I mean, okay, there is a long way of doing this, and there is a shortcut that I told you in Calc1. But let me first of all do it the long way. Basically, what you should be doing when the limit form is infinity over infinity, plus or minus infinity over plus or minus infinity. When that's the limit form for a rational function, the trick that we applied was factor out the highest order term. So in the numerator, I'm going to factor out x, and that's going to give me 3 minus 2 over x. In the denominator, I'm going to factor out x, and it's going to give me 2 plus 1 over x. And now I can cancel out the x's. And now you ask yourself, what's the limit? As x gets bigger and bigger and negative, right? 2 over x, what's happening to 2 over x? It goes to 0. 1 over x goes to 0 as x gets bigger and bigger and negative, right? You're dividing by a big number. Even though it's negative, it's a big negative number. And so you get 0, and you're left with what? 3/2. And the other way that I was talking about is that when you're looking at the limit as x goes to infinity, that means you can assume that x is big, right? And when x is big, the value of a polynomial depends on only the highest order term. So the limit of a polynomial when x goes to infinity is only determined by the highest order term. So when you take the limit here, you can ignore all the terms and just consider the highest order terms in the numerator and in the denominator. Okay? So if you ignore the lower order terms, then basically what you're getting, so basically the other way of doing this would be that I am looking at the limit as x goes to negative infinity, 3x minus 2 over 2x plus 1, and this limit would be the same as the limit as x goes to negative infinity of 3x divided by 2x. What did I do? I ignored all the lower order terms. I only considered the highest order terms in the numerator and in the denominator, right? Is everybody okay? And what's the limit now? Well, now it's obvious. You just cancel out the x's. You're left with 3/2. Okay? And this is just for rational functions. And this is what you can do when x goes to infinity or negative infinity. This wouldn't be true if x goes to 2 or something. If x is going to a finite number, you cannot do this trick. But if x goes to infinity or negative infinity, you can ignore the lower order terms. Everybody's okay? Yeah.
What are those like 3x cubed?
Same trick. Same trick. So if it is 3x cubed, you're going to end up with 3x cubed over 2x, right? Well, when you x cubed, then x cancels out to what? X squared. What's the limit of x squared as x goes to negative infinity? Positive infinity. So your answer will be positive infinity. Is that okay? Same trick applies, but your limit would be obviously positive infinity. Any other questions? All right. Next example. Let's say I have the limit as h goes to 0, 9 plus h minus 3 divided by h. Okay, so what should I do now? What's the limit of the denominator here? 0, right? What's the limit of the numerator? So the limit form is 0 over 0. And in this case, of course, I shouldn't try to factor out. I should be doing what? That's the cliche. I keep saying the same thing over and over again whenever I see root functions, right? The cliche is, you see root function, you do what? You rationalize, right? So you rationalize by multiplying by the conjugate. So I would be writing minus 3 over h times 9 plus h plus 3 over h. And oops, really? 9 plus h plus 3. So I multiply and divide by the conjugate, and so doing that doesn't change the quantity because I'm essentially multiplying by 1, right? So what should we do? We multiply the numerators and the denominators. However, should I be multiplying out in the denominator? No, because remember, the entire goal of doing this is to get rid of the factor that gives you 0 in the denominator. The factor that gives me 0 in the denominator is h. So I need to get rid of that h. Therefore, I should not be multiplying out in the denominator. Just keep it as h times this. A lot of the times in exams, I see students multiply out in the denominator and then they get stuck. They don't know what to do. But you shouldn't multiply out in the denominator. In the numerator, you should. If you multiply out in the numerator, what do you end up with? 9 plus, you guys realize that? When you multiply out in the numerator, you basically get the square of 9 plus h, root of that. You get the square of that minus the square of 3, right? You agree with that? Just multiply out by using FOIL if you're not comfortable with what I just wrote. And you will see that you end up with that. And then that's equal to what? That is equal to the limit as h goes to 0. This would be 9 plus h minus 9 over h times the root of 9 plus h plus 3, and this would be equal to the limit as h goes to 0, h over h 9 plus h plus 3. H cancels out. Now you plug in h equals to 0 again. If you plug in 0 for h, what do you end up with? 1 over root 9 plus 3, which is 1 over 6. Is everybody okay with that? Okay, here's another example. Suppose that you are given f of x is equal to root of x, and you need to find f prime of 4 by using not the power rule, by using the limit definition. Okay? It's still important to remember the limit definition of the derivative, okay? You cannot forget about what's the limit definition of a function. It's not enough just to remember the formulas and be able to apply that, because from time to time we need to know what's the original limit definition of the derivative. So what is f prime of 4? Well, first of all, what is f prime of x? F prime of x is the limit as h goes to 0 of f of x plus h minus f of x divided by h, right? That's the limit definition of f, of the derivative of f. But we want to know f prime of 4, right? So I'm not going to, if I want, I can find f prime of x for any x. I can just compute this limit, but I won't do that. I will just look at f prime of 4, and f prime of 4 would be the limit as h goes to 0 of f of 4 plus h minus f of 4 divided by h. You agree with that? What is f of 4 plus h? Remember, f of x is what? F of x is root of x, so I can then plug in that, so I get the root of 4 plus h minus the root of 4 divided by h. And then what? Well, then it's a usual limit problem. So I get basically 4 plus h minus 2 divided by h. And what should I do once again to find the limit? Once again, to find the limit, I should be multiplying and dividing by the conjugate. So this is 4 plus h plus 2, 4 plus h plus 2. And so this is equal to the limit as h goes to 0. When I multiply out in the numerator, I'm basically going to get 4 plus h minus 4. Okay, and basically you're going to end up with h. I don't want to go over the multiplication. And in the denominator, of course, you have h times 4 plus h, root of that plus 2. And then you cancel out the h's. When you plug in 0 for h, you get what? 1 over root 4 plus 2, which is 1 over 4 at the end. Is everybody okay? The reason I did this problem, not the limit problem, just to remind you what's the limit definition of the derivative. Okay, so that's what you want to take out from this example. Any question, anyone? No? Okay. Remember this limit as theta goes to 0, sine theta over theta is what? 1. Okay, so let's do an example involving that. So suppose I need to know the limit as t goes to 0, tangent of 60 over sine of 4t. So how would you find this limit? Tangent to sine and cosine. Okay, so this would be equal to the limit as t goes to 0. First of all, what I'm going to do is write this as tangent of 60 times 1 over sine of 4t, and then I am going to convert tangent. In problems involving trigonometry over and over and over again, what happens is that you need to apply some sort of identities, right? So this is no exception. You have to know that tangent of 60 is the same as sine 60 over cosine of 60, and then I have that sine of 4t here, and then what I'm going to do is rewrite this again, and I'm going to write this as sine 60 1 over cosine 60 1 over sine 4t. Remember that the limit of sine theta over theta is 1. If I want to use that fact, what do I need in the denominator here? I need a 6t in order to use that. What do I need on top of the third factor? I need a 4t on top of the third factor in order to use the limit, the fact that the sine theta over theta goes to 1 as theta goes to 0, right? The angle 4t must match the numerator, right? And so, what did I change here? Remember, I introduced 60 in the denominator, which wasn't there. So because I introduced 60 in the denominator, how do I cancel out that effect? I multiply by 60 in the numerator. I introduced a 4t in the numerator. To cancel out that effect, I need to divide by 4t, right? I introduced 60 in the numerator, so I have to divide by 60. I introduced 40 in the numerator. I introduced 60 in the denominator, so I have to multiply by 60 in the numerator. I introduced 40 in the numerator. I have to divide that by. So this quantity here, that's basically what? 3 over 2, right? Okay, so now what's the limit of this guy? What's the limit of this guy? And what's the limit of this guy? This guy goes to 1 because the limit of sine theta over theta is 1 as theta goes to 0. So here the angle 6t, right? Does it go to 0? Yeah, so 6t goes to 0. So sine 6t over 6t will go to 1. Same thing happens here. It's going to go to 1. If sine theta over theta goes to 1, then theta over sine theta will also go to 1, right? And what's happening here? Well, just plug in 0 for t. What do you get? 1 over cosine 0. Cosine 0 is 1. So you get 1. And what's this quantity here? 3/2. Okay, so at the end, what we get is 3/2. Are we okay so far? Screen okay? Okay, so let's take y to be the function x squared plus 4x plus 3 divided by root of x. And what I want you to find is y prime. So now we're going to practice some derivative problems. What's the derivative of this function? Well, one way to do this problem is what? Quotient rule. However, I'm not going to apply quotient rule here. You can apply, which is fine. But you have to be aware that whenever you apply quotient rule or product rule, you have to do work to simplify that, okay? But if you could do this problem without the quotient rule, simply by using the power rule, then you get a more simplified answer right away, okay? So for example here, instead of using the quotient rule, what I'm going to do is basically do some algebra ahead of time. So I'm going to rewrite this as x squared divided by root x plus 4x divided by root x plus 3 over root x. I could do that, right? And let me erase y prime for now. So what is x squared over root x? X squared divided by root x is what? X to the 3/2. Because root x is actually half, right? So 2 minus a half is 3/2. Plus 4 times x over root x is just root x, which is x to the half. And what is this? 3 times x to the negative half. And now I'm going to take the derivative by using the power rule. So this would be what? 3/2 x to the 3/2 minus 1, right? Plus 4 times the derivative of x to the half. Half times x to the half minus 1. Plus 3 times the derivative of x to the negative half would be negative half x to the negative half minus 1, right? Alright, at the end, what am I getting? I am getting 3/2 x to the half plus 2 x to the negative half minus 3/2 x to the negative 3/2. Okay, you guys agree with that? Okay, this is a good enough answer, but if you don't, in some cases you don't want to have those negative exponents. So what you could do is factor out the largest negative exponent of x. Okay. Here, what I'm going to do is I'm going to factor out a half. We have taken the derivative. I'm just trying to show you simplification. to get rid of negative exponents. So I'm going to factor out a half, and I'm also going to factor out x to the negative 3 half. This is one way of simplifying. There are other ways too. So x to the negative 3 half. If I simplify, if I factor that out, what do I get? In the first term, when you factor out something, what do? You divide each term by that, right? So if I divide the first term by what I am factoring out, what do I get? What is this divided by this? Well, 3 half divided by half is what? 3, right? What is actually half divided by actually negative 3? Negative 3 half. When you divide, you subtract, right? So half minus 3 half, right? What is half minus 3 half? Half minus 3 half is 2. Everybody is okay with that? So this will be x to the 2, because half, basically you end up with half plus 3 half, right? So that's 2. Plus, when you divide, now we're looking at here, we're dividing this by this. What is 2 divided by half? 4. What's x to the negative half divided by x to the negative 3 half? It will be negative half minus negative 3 half. So it will be negative half plus 3 half, which will be what? 1. Minus 3 half divided by half is 3, right? And what is what am I getting here as power of x? Actually 0, right? Which is 1. So now all I'm going to do is rewrite this as x squared plus 4x minus 3 divided by 2 times x to the 3 half. Okay, so I don't have any negative exponents anymore. Is everybody okay with that? Yeah. Say it again. I missed a 3 out from. Oh, this right here, a 3 missing. Thank you. Everybody's seen that that mistake? I had a 3 half actually half, right? 3 half actually half. So when you divide 3 half by half, you get a 3 half. All right, everybody's okay. Let's see other examples. Okay, so let's look at. This is an example similar to your web assigned homework. Suppose that I have a function f of x, which is 3x, which is 3x plus 1 to the 3 times 1 minus x squared to the let's say 4.